So look into how Near runs WebAssembly, 2-second finality, which is also AKA Doomslug, if you want to look into that, and then look into how Near handles sharding, and is specifically sharding state, which is in Nightshade, which I think is very, very interesting. And the most, as a developer, like I'm a little bit more on the development side, like I'm not this like low level protocol side. As a developer, I was super attracted to the fact that Near is sharded, but it looks like one blockchain to you as a developer. And when I really wrap my head around this asynchronous non-blocking calls, and the fact that like you can like fan out and do like a lot of parallel calls to other different contracts and like sort of search for data, like who has the best swap. Okay, now I'm gonna bring back the best possible swap options, and I'm gonna actually have a matching engine inside my contract that's gonna aggregate all of that, right? When I wrap my head around all of that, it was like super fascinating, and it's like really quite a powerful feature. So let's talk about Aurora from a consumer point of view. So this is called the Aurora Plus, like dashboard service, user experience, whatever you want to call it. It's Aurora.plus. So what it is basically the Aurora team wants to be able to onboard new users to crypto with relatively fee-free. So what they did was they made this Aurora Plus thing. You can just sign up with your email and using a MetaMask wallet and stuff. And they basically give you, they give you 50 free transactions a month, and they let you, explore the Aurora ecosystem. You can also you can stake your Aurora. It's sort of like your portal to Aurora. This is all like DeFi on Aurora here, and you can do stuff, change your email, link different wallets, do stuff, right? So it's very like fun and user friendly. They just launched this a couple of weeks ago. I think it's pretty cool. It's sort of like if you were going to launch an app on, if you were choosing anywhere to like sort of write your Solidity contracts and deploy them, and you wanted easy onboarding. So all of your customers, the market was saying like, hey, our customers don't understand crypto. They don't know what they're doing. They don't know what gas is. They don't know how to pay for transactions. This would probably be a good avenue because it would help you out. This is the Aurora developer webpage. So this is basically just shows off a lot of kind of big name crypto projects are already kind of launching, or in the sense of Curve or something, it's relaunching on Aurora. ETH Scan does support Aurora. There's total value lock, so that number is higher than the Near number. So I think that they're counting Aurora as something separate, or their number's wrong. I don't know. This TVL stuff. I don't know. I don't know what they're counting. But projects on Aurora, 113, pretty cool. And that's just sort of a snapshot from the Aurora developer website. This diagrams that flow. So again, the user is going to sign a transaction. It's going to go to a special RPC node. So I think people are relatively familiar. RPC is just basically going to kind of relay your transaction to the blockchain. So basically it wraps the Ethereum transaction into a Near transaction. So these RPC nodes have to be special. They have to know how to take a signed Ethereum transaction and translate it into a Near transaction. Then they send the wrapped transaction. They unwrap the transaction, calculate the Near gas usage going forward to basically commit the state on Near protocol, and then it sends the signed Ethereum transaction as a parameter to the Aurora engine. So this is where it gets really crazy. Aurora is just a smart contract on Near. At the end of the day, that's what the Aurora engine is. Now, obviously, RPC nodes that can speak to MetaMask and do all this and talk to all Ethereum wallets and do this translation from a signed Ethereum transaction into a Near transaction that can go inside this contract and do all this fancy state management, because the near virtual machine is obviously different than the EVM. All of that stuff has to happen around it, but at the end of the day, what's kind of interesting is it's just a really fancy smart contract on near. And then this says performs ETH payout to proxy in accordance with gas price from Ethereum transaction. I don't know who the proxy is. I mean, sorry, again, I don't know where the ETH goes, guys. I probably should have looked it up. But yeah, you guys could probably figure it out pretty quick. But I know that some ETH gets burned in accordance to like EIP 1559 because they don't want to. So they don't want to just be like an ETH, what's called like an ETH sink, or they don't want to just take ETH from the ETH ecosystem. Like, hey, bridge your ETH here, spend it on Aurora, and then we'll go dump it. They want to be fair with the Ethereum ecosystem. And if protocols are launching on Aurora and they're saying burn this ETH, they burn the ETH. So that's kind of cool. Yeah.
Something doesn't make sense to me. When you send ETH to Aurora's validate source, you are actually doing that EIP 59 journey because you are doing this on top of Ethereum. Because that's ETH, not like wrapped ETH and not Aurora.
When you're bridging ETH?
Okay, so you're bridging ETH
from Ethereum to Aurora?
No, I mean, okay, got it. So you bridge ETH, and then after bridging, you also do another burning. Is that right?
Well, I'm talking about when users make transactions and the ETH is designated to be burned, like by the protocol, because there's this EIP 1559. That I'm just saying, like the Aurora team respects that, and they basically will burn the ETH in accordance to EIP 1559. They don't just take the ETH.
So they are actually taking wrapped ETH or the ETH exactly?
Okay, so I think let's go back in your question. I think you're talking about where does the ETH come from in the first place, because this is all happening on near, right? So what is this ETH, right? Okay, so that's a really good question. This is basically bridged ETH. So it's bridged ETH from Ethereum, but it's basically ETH that will not go back. And then I'm pretty certain that the way that they burn it is that they go back to, so everyone that needs to bridge ETH to near or Aurora, the ETH gets locked up in some contract. If it's burned on the Aurora side, then they run the bridge. So they'll basically send some thing back to burn on the ETH side. So it'll get burned at some point.
Okay, so whatever transaction that's being made on Aurora on wrapped ETH affects the real ETH and burns something on. Okay.
Yeah, it's kind of weird. It's not actually wrapped ETH. It's super weird. It's ETH, but it's not. It's like synthetic, unwrapped ETH. If that makes sense. It's like a near version, but it's not like wrapped ETH as in the WETH on Ethereum, if that makes sense. It's not an ERC20 ETH.
So the bridge essentially is like any other wormhole or whatever bridge, where you have a locked contract on one side and then a new minted token on the other side. In terms of security, how do they guarantee that you're not doing the double minting or double spending on either side?
So they run a light client on both sides, and basically they don't until there's X number of confirmations on one side, they don't create it on the other side. So basically, but the thing is, it's like the near light client that looks at Ethereum headers or transactions or proofs that you've done what you've done on Ethereum. It has to basically verify it, but that all happens inside a smart contract. So it's kind of like you're going to deposit your ETH on the ETH side, and then you have to wait, but you have a proof of that being done, right? A block header or something, and that block header is basically burned into a near contract, and then there's a light client which is going to basically look through those block headers and verify that you've actually done that transaction. So it's super complicated. It's like this process of these light clients are these process of verifying like Merkle tree proofs. So you have like some data, and then you're coming into the smart contract and you're saying, no, I did this transaction, it's way down here, and then by virtue of having like a hash of and like a whole tree up to the root, that's the block header that was burned in from the moment you did do it. So you like deposit, block header goes into the near contract, then you have to wait though, because you have to wait until a certain number of other block headers are like burned in, because that's like block confirmations on the ETH side. That's why to go from ETH to near, it takes 10 minutes. You just have to wait, because otherwise they're not really sure that you did it, because of course the Ethereum blockchain could like reorg itself into something, different, where you didn't do it. Yeah. All right, I'm gonna move forward, try to get through the rest of it. So anyway, sorry I don't have all the answers to this ETH stuff, but I mean, the team, like the Aurora team's pretty open and transparent about what they do with ETH and how they handle it and things like that. I mean, let's just say, guys, I'm glad it's not another token, right? I mean, because that would be bad. It would be like really annoying to have to go get some other token. So deploying a contract using Truffle. I took this screenshot from the dev docs just because I wanted to show you guys, but also if you're familiar with ETH development, you've probably heard of Truffle. It's been around since I was building stuff on ETH. And then there's also Hardhat, which is like a new one on the left-hand side. And so they support quite a number of the tools, and they have docs and guides to guide you through. There's not a lot you need to change. There's just a couple of things. I had a couple of buddies, they had a DeFi protocol. They basically asked the Aurora devs like 1 or 2 questions, and then they had it deployed. So it took them like an afternoon. And it was, it's not a trivial protocol. It was something else. So this is Aurora Scan. So Etherscan does support Aurora, like on the actual Etherscan website and stuff, but this is called Aurora Scan. They just like cloned it basically. It's kind of cool. So I mean, you can go check out your transactions. They show you token transfers and all that stuff. And the Aurora ecosystem is growing. And shout out to the top left there, Vancouver company Covalent. Where are the Covalenters? What do you call each other?
People who work at
Covalent. People who work at Covalent. Okay, and by popular demand of this gentleman over there, I included a graph. Would you like to explain this graph to us?
I would actually. I said it's before. I thought it was fun. So he said he was speaking, and I was like, oh, let me get you some data for your presentation. So these are actual growth of Aurora users. So some of these are people who swapped over from here, and some of these are just total new users that are just making changes. So there's currently 800,000 active vaults on Aurora.
All right, so that was total users, and then what's existing users?
I was in front of my computer.
But boy, does that chart look sexy.
Yeah.
The users are going way up.
There's lots of growth. It's actual growth. It's not yeah, it's actual growth.
Okay, so Covalent, do you want to give us a quick spin on what they do? 30 seconds?
Yeah, Covalent is a direct replica of 40 blockchains. We take all historical blockchain data, put it in a database, make it useful for data. That's it.
All right, so if you need data about the blockchain, you can query it through Covalent. All right, cool. So that's all I had planned for I had a whole bunch of supplementary near metrics and kind of stuff. We don't have to go into it, but I can share this out as well. It's just bit.ly/Matt, 2 T's, near, if you want to go to it. It's really simple, Matt near. Yeah, so that's all I had planned. That's the near stuff. This is aurora.dev, check it out if you're a developer. And then Aurora, I mentioned Aurora Plus, aurora.plus if you just want to sign up, get free transactions. And then this is the proximity stuff, and if you want to follow me on Twitter. That's all I had planned for the main show. All right, thanks.